In this issue of the Chronicles of JavaScript, we are going to work on building a real simplistic version of a chatbot. So we're going to create a simulation of a thinking computer or an AI so that it has some things going. So when we look at what I have on screen here, the computer is asking me a question, so I'll type a response and put it in, and I can see it's now responding to what I said. And I'll say no. And now it says, oh, well, that wasn't very nice of the computer. So, okay, so apparently our computer, our AI, has a little bit of an attitude going on here. So maybe we can address that. But the real topic that we're working with here is not to create a full functioning chatbot, even though there's plenty of examples on websites where the chat pops up and, hey, can I help you? Or do you want more information? And often they're annoying, or because you realize very quickly you're not talking to a person, but instead you are talking to a computer that's looking for specific keywords in your answers. And when it finds those keywords, then it sends it down a track where it can then provide you with potential answers based on those keywords that it detected in your response. And that's really what it's about. Now, the technique that we're going to be using for this involves arrays. Now, arrays are a wonderful thing in JavaScript. They're super powerful. They can do lots of things. We're just barely going to touch on them. But an array is simply a collection of items. Now, the syntax that we use is we use the square bracket notation, and then we put the items in the array separated by a comma. That's all it takes to make an array. One method we will use on an array is length. Length is how many elements are in it, so we can say fruits.length, and that came out with the answer of 2 because there are 2 items in that array of fruit. The other thing that we're going to use is a way to search through that array to find out if an element is in fact in that array, and we do that by using the indexOf method. And what it does is it returns the position or the index of that item in the array. So the first element is at index 0, then 1. So that's why when we do index of bison, it returns 1, 2, 3, 4. So there's 5 elements in the array. We start counting at 0, 0, 1, 2, 3, 4. But if we ask for something that's not in it, what is the index of giraffe? We look at the array. Nope, there's no giraffe in it. And it will return a value of -1. So these concepts of building an array using square bracket notation, using length, and using indexOf are the primary tools that we're going to use to build our AI chatbot. So to build up our script, the first thing that we need to do is access our different elements that we wish to be able to manipulate. So I'm first going to set up the computer. And we'll use query selector because it's convenient. And with that, I can then use hashtag computer. So then that matches the ID that has been associated with it. Now, what I can do here next is access the human. And I didn't put an ID on it. I only have one input in this particular example project. So that means we can simply get the input. Now if I put an ID on it, or if I put some other way of designating it, I could do that as well. And finally, we'll grab the button. Now, just for fun, because we're dealing with arrays here, what we're going to use is get elements, notice it's plural, elements, by tag name. Look at the camel casing on that. Code completion is helpful so you don't have to remember it. Well, gotta type the correct tag now. And I'll say button. But what's interesting about this is that when we grab elements by tag name, it actually grabs those elements and stores them in an array. And then we can access those elements in that array by specifying their position. There's only one button, so its position will be at 0. Otherwise, it would be in line order as those elements appear. So say I had like 6 paragraphs, and I said get elements by tag name P, in quotes, then I could use square brackets to designate which of those elements I was trying to access. So that's a quick way that we can go about setting that up. Now, one thing that's nice when we are working with forms like this is to set the focus on it, because right now when I look at this, it's not ready for me to type in it. I have to click in the input field and then I can start typing. But by using a simple line of focus, now when I look at this, and this page is active, it's ready for me to start typing, which is pretty cool. So with that, I'm going to set up a few more variables that we are going to be using as we work our way through this, and we will explain them as we use them in a little bit more detail. But first we have the response number. The response number is going to store the value of it, because remembering we access elements in an array by their number or their index number per se. So it's the index number, just like we're using 0 to access the button. So if we use our index number in an array to get things, then we want to be able to store that so we know which one we're working with. And then we will want to track the new response the computer will give back to the player. And we do this as a means because eventually we're going to want to be able to control so we don't show the same response multiple times to the player, because then that breaks the illusion of the chatbot. Next, we have the human message. This is going to be the text that has been provided by the player, so it's the value of the input. So when they type something in on that input and we push the button, we're going to store that information inside this variable, and we'll call it human message. And then we'll have our computer message, and this will be the text that the computer is going to be responding back to the player with. So that gives us a starting point of some of the variables that we are working with. And next, what I want to do is set up my event listener. So we'll tell our button, add event listener, the event will be click, and then we will have our click handler and false. Now, what I also want to do is to tell my window to add event listener, and this, well, let's get our keys correct here. This will be the key down event. So we did use this previously. We'll have our key down handler and false. Because what I want to be able to do is, as I type in that input field, I don't want to have to then take my fingers off the keyboard, grab the mouse, click on the button. I want to be able to also hit the return or enter key as a way to submit what I have input in that text field. So now with that, let's define out these two items. So we'll say function click handler, and then this function is going to call a new function we'll be making shortly called play game. Oh, don't want cap locks on. Function, and this will be key down handler. And remember, you can, when you see it giving you hints for code completion, start typing additional letters that are present there so you don't have to type everything. That speeds up things greatly when you're working. So now we want to know if the key code of that key down event. Well, we didn't put anything in these parentheses parameter. So commonly when we're tracking events, because we're using an event listener, so we're using an event listener. So when we're tracking those events, we designate the parameter. We either use E, EVT, or event. All three of those are permissible as part of it. I tend to use E more often than not. So of that key down event, which we're calling that event E, if the key code, and it's camel cased, is 13. So remembering that every key that we press has a key code associated with it. So if we wanted on this key down handler, I could just log my keys to the console and start typing keys and find out what key is associated with what key code. And I know from experience that 13 is going to give me what I want. So if I press that, I want it to call the function play game. So that means we now probably need to define that function. And we'll just do function play game and log. I'm going to just log that out. Game. Okay. So now we know that that is there. I don't see any errors showing up in my console. So I did start the live server here. I think before the video started, so I already had it running, but I clicked to start my live server. You can also get to live server by going to the command palette, and it will give you previous things you've done, of which one of those would be open the page with live server. So you could choose that as well. So now if I click the button, it should give me a message in the console. And if I type something and hit return or enter, it also gives me something in the console. I just adjusted my window so I can actually see it's now showing me which line that happened from. So that tells me everything is working. With everything working, it's time to start playing the game. So we don't really need to log that out anymore. I'll just comment it. I'll delete that later. But what I want to do is I want to do a little bit of analysis of what has been provided by the player. So the first thing that I'm going to do is take my human message and I'm going to set it equal to human.value. So that's the contents of that input form, and we're going to use a cool JavaScript method to lowercase. Hey, look, there it is. So I could go L, and now let's type C to lowercase. Hey, look. So now if I hit enter or return on the keyboard, puts it in so I didn't have to type everything. That's pretty sweet. So now human message has been put to all lowercase, and that's because if when they're responding, if they type, because we say how are you today, if they said good, that would give me one value, but if they said capital G-O-O-D, or if they did G-O-O-D or G-O-O-D, all of those are as far as values are concerned, different strings. They're not the same value. So, well, and especially the final one, because there's one too many O's. So the first thing that we want to do so that we can analyze it is to knock it all down to lowercase, because then when we do that, they all just become good. And when it's good, then we're in good shape. The next thing that we want to do is we want to analyze and find out, hey, now most of the time if you say, hey, how are you today? People are going to say good. They might say bad. Now we could look for other options as well, but those would be theoretically two of the more common responses. So I'm going to say if human message dot and the index of. So we're going to be scanning this string. It's really cool. We get to use the index of method so we can then scan and look for it and find out, hey, is that there on that string? Because a string is kind of like an array. It's just a whole bunch of characters. So we're looking for a particular word. The word we're going to be looking for is good. So if the index of good is not equal to -1, meaning we found it. So if they said, I am good, good I am, do they use Yoda speak or normal language? But if they did, it's going to return a value. So if good exists anywhere in their response, anywhere, it's going to return a numerical value telling you within that response what is the index position of where that started. And when that happens, then at that point, we're going to update the computer message, and we will set the computer message equal to something. You know, in this case, I'll say that, well, no, this, that, whatever. That is good for you. All right. So that now updates the computer message. And we'll add some more to this in just a moment, but I want to get to seeing something happen here. And we'll just do an else. So we'll look for bad or some other things in a moment, but else, we'll say computer message is equal to, please answer the question. And then finally, what we want to do here is say computer dot. Now remember, computer is the computer's paragraph. So if we look up here, paragraph ID equals computer, where the computer's text is appearing, and we will just change the text content to be equal to the computer message. Let's save this and see what happens. So if I say bad, it says please answer the question. Oh wait, it still says bad in my response there, but now let's just try if I say good. Oh, so it's working. But what would be nice to have happen there would be to then set the value to say human.value is now equal to empty string. All right, so now let's click over here. Good, and now it's empty. So the computer's provided a response, but it hasn't then provided a follow-up question. So we want to provide a follow-up question. We also want to be able to start working through more of it. So this is where we're going to start looking at how, when we play the game, we can start figuring out responses and storing responses and analyzing those, and then asking particular or specific responses of the computer. So before we get into some more of that, what can a deep question with it what we can do is, instead of saying something like, please answer the question, we could have a list of responses that the computer can work with. And let's just call this generic responses, and it's going to be an array. And in this array, we'll just populate it with a bunch of strings or responses. And I can say, good for you. Now, comma, and now in the next line. And we can use single quotes, double quotes, both. And you can even mix and match, and no harm, no foul. It's fine because JavaScript really does not care. So after each element, we want to include a comma. And with modern JavaScript, we can even have a comma after the last item in this. But we don't have to. Now I put all of these on separate lines. It makes it easier to see what we're doing. It's easier to deal with it. We don't need to. It could just all extend into one long because they're short phrases. But if you have longer responses and you want to and don't want it all on one line, you're welcome to do it. But I find it's much more readable writing an array in this manner. Now, this generic response is at position 0, then 1, then 2, then 3. I have 4 items, so the length of my array is 4, and the positions are 0, 1, 2, 3, because computers do like to count that way. So instead of having a fixed response if it doesn't know what I've said, what I could do is figure out a way, and I could say new response is going to be equal to math.random, and we know that, well, we want to grab it out of generic responses, the length of that, which, you know, we know that math.random returns a value between 0 and 1. And if we take that and multiply it by the number of choices that we have, in this case it would be 4, which is the length of my generic responses.length. That way if I add more generic responses, my code doesn't break. And we need this to turn into a number, and we need to round that number down. Because if it's giving me a random number between 0 and 1, so if it somehow comes up with 0, 0 times the length, which is 4, it's still 0. But now if it's 0.5 times the length, well, that's 2. So we see how we're able to use this random number between 0 and 1, multiply it by the range of numbers that we want, and then we need to round down, and to do that we use math.floor. So anytime we want to use any of the math operations in JavaScript, floor, random, etc., we have to preface it with math. Math is capitalized. So we do math.floor, parenthesis, math.random, parentheses, because that generates a random number. And we take that random number and multiply it by the number of responses. This way, if we get, a random number is 0.78, and then 0.78 times 4, we do the math, round it down, it gives us a whole number, and the numbers that we're going to end up with when we're all done here will be 0, 1, 2, and 3. If our generic responses gets longer, well then it gets longer. If it gets shorter, it gets shorter. So that's how we're able to figure out which we want it to be for that new response. So instead of hard coding text, then all we have to do is say generic responses, and then remember when we're accessing an element in an array, we use square brackets, and now we just pass in new response. Technically we could have done it all on one line, but that would have been super ugly. It's easier to do it this way, and we're going to, when we start not wanting to have the same thing repeat, this is going to be a better solution, and you'll understand that as we go forward with it. So now if I go back into this, and if I type in bad, return it says I like you. Okay. And technically now I can just keep hitting return because it doesn't care if I answer it or not. So we can see that, yeah, I'm pressing it, and you can hear that, and periodically it gives me the same one multiple times in a row. So that's not necessarily how I want to do it. So we might want to try and figure out a way to not get the same one 2 times in a row, or only use a generic response once and after that delete it. And that's one of the cool things that we can do with arrays, is that we can remove something from that array. We can splice it out. So we can extract it, cut it from that array so it's no longer part of it. So in order to do that, I'm going to construct another function, because otherwise I'm going to have ifs inside of ifs and if else's, and it just gets messy. So I'm going to have this be my generic I'm just adding a little one more word, so it'll be my generic response calculation function. Added the word calculation on there because I don't want to have it confuse you, because I could just call it generic responses the function, but I have generic responses plural as my array, and then that could be at times a little bit confusing. Now the color coding should hopefully keep things straight for you, variables versus functions, but still, trying to be helpful with that. So what that means is we just go and call the generic response calculations. We just call that function, and then we're going to put this information. So I'll just cut that out of there, paste it in here. We're going to be working with it, but what we want to determine is if generic responses dot length is greater than 0, because what we're going to start doing is every time we use one, we're going to cut it out or delete it from that array. So if generic responses is greater than 0, then we're going to do this stuff. Else, what we're going to do is say computer message is going to be equal to I do not like you. I am done. Please leave. So yeah, our computer is less than nice. Now we're going to look at a few other kind of gimmicky things that we can do with it, where we can make our page go to a new URL or something like that, so we can have some fun with it. But in the meantime, we'll just let it become that. So now what we want to do, just move these up, move these over, so get our proper formatting and indenting. And I'm just going to delete that extra stuff so it's a little bit cleaner. So we figured out our new response. We've set up the computer message, and then what we're going to do is take our generic responses, and we will use the array method of splice, and then we're going to remove at that position because we used this new response to figure out what that response is. And when we use splice, we can say how many elements we want to remove. So we say starting at which index position and how many elements, in this case 1, we want to delete or remove from that array. So what I'm going to do is on this next line, I'm just going to log out generic responses. And that way we'll be able to see what's happening here. This also means we won't see the same thing happen twice because once it's gone, we can't answer it again. Okay, no error messages. I like that. So we can just hit enter. Now we can see there's only 3 items in the array. So it said you need to get a life, but now it left those 3. Now if I enter again, now there's only 2 items. It said go away, and we can see up top where it said go away please. That's no longer part of that array. Now if I do it again, now there's only 1 item left in that array. Good for you. Now the array is empty. So this is the test. Does it give us the response of telling us to go away? And yes, it does. Now, one thing that as we do this, we can see when we get a longer response, it moves it over. So what I'm going to do is go up and just adjust the style over here. I'm going to just throw some padding in. Let's just do 1em, just to put a little bit of that. Now we'll just choose a background color, and we'll just find something that is subtle. And I'm just going to make it a little lighter, so I'm not going to bother with changing my text color. Now we have our RGB on that. And let's see how this looks. Does this clean it? Okay. Oh, and finally, what I want to do is just set a width on here so it's a little bit bigger. All right, that works. Change the background body, but now as we go through, we can see it doesn't keep moving, and I just find that to be a little bit more satisfying while we work with that. Okay, so the CSS, yeah, that's not the point here, but it's always good to reinforce concepts while we're working with it. So just a quick recap. So play game. If it doesn't find an answer that has good in it, it's going to call our generic response calculation. And then that is going to find out, do we have any generic responses? If we do, let's go grab a random one. I'm going to stop logging that. We don't need to. We proved it works. And it grabs a random response, updates the value for computer message, and then it takes and removes that response so we can't have it happen again. Finally, if there are no responses left in our generics, then it does this hard-coded response right here, which says, I really don't like you. And now to have a little bit of fun with that, I'll just call set timeout, which is a JavaScript method where I can now do something. I'm going to call a function that I'll have to write here in a moment. Endgame, not the movie, but it's a function. And we designate in how many milliseconds we want that to execute. So it sets a timeout. That's like doing a countdown. So this says countdown 2 seconds. So 2,000 milliseconds. So it counts down those 2 seconds, then it will call that function. So this is where we can have some fun. Again, we're not doing the movie, it's just the function endgame that we have now named, and we're going to make something happen with it. So we can update the location of where we are. This is, one of those things where we are now doing, if you've ever been on a page where it does an auto redirect, that's pretty much what we're doing right here, because we're assigning. Now we have two options when we send to a new page. We can allow it to remember where we were previously using assign, but we could also, instead of assign, say replace, and then that effectively erases any of the previous steps in the history for that tab, so the back button won't work. I would discourage you from doing that right now. And then with this, we just need to figure out where we want to go. And if the title of the project wasn't information enough, there was a movie that came out a while back called Electric Dreams. So let's see. So if we go through our different responses here, wait our 2 seconds, and it now goes to the wiki page for Electric Dreams, which is a movie where we have a love triangle with a man, woman, and computer. So make of that what you will. Now notice I do have my back button working, so that is useful. I like that. What I'm going to do, though, is show you if we use replace instead of assign, put the C, not an S. So if I replace it, when I go through here, now 1, 2, and now we're here, but the back button is gone. So that's problematic. I'm going to just put back in my page. So just be aware, if you use replace, it's kind of mean to the user. Assign does allow you to use the back button, but it kind of adds a little bit of fun, because remember, we are playing a game here. The next phase of this project is to then have some more complex analysis of answers, so that as we ask questions, we look for those possible answers, and then those answers set up a track of further question answer possibilities. So we break it into a series of things, and the best way to start planning that out is to actually build a flowchart. So moving into this next phase of building this into a more complex project, what we're going to be doing is analyzing the responses. So currently we just said, good. Now, what if when we do this, return here, I'm going to add in curly brace and say else if, now in this point we'll say human message dot index of, and we'll go with bad. So if the index of bad is not equal, now you will notice that first example, we have 2 here. Sometimes we can use 3. In JavaScript, what we're doing, double equal signs are always a comparison. Single equal signs are assigning a value. So we're saying min value is going to be equal to an empty string. Here we're asking a question. We have the exclamation mark, which is for not, meaning we want to know if it's not -1. We don't care what the number is, we just want to know that it's not -1. And just add in my next curly and get rid of that. And now, okay, I feel better. The underlining code telling me I was mismatched. Now I did spell human wrong here. We got an extra M. Oh, there we go. Human message. That makes more sense. All kinds of typos going on. So anyway, we can use double or triple equal signs if we are working with it. The triple is going to be, is it an absolute comparison, same type and value, or double is whether it's same value. This is the equivalent of, if we wanted to know if it was -1, it would be two equal signs, or 3 to say it's -1 and it's an actual number, because this in quotes -1 and -1 would technically have the same value, but if we use triple, it would have -1 or -1 inside quotes do not have the same value because one is a number, one is a string. So this is moving into some of the more finer points of JavaScript. But right now, just suffice it to say we want the single or the double equals and an exclamation mark for the word not, because we want to know that it's not -1. Because again, if we index of on a string or an array, when it returns -1, that means it did not find it. Now, what we can do is go computer message is going to be equal to, and we can come up with a different option on this as we figure it out. And it could say you sound depressed. If we want our game to continue, we need to take all of our responses and ask a question afterwards, so then they respond with something else. So I will say, do you like dogs? Now that is a yes or no question. We could also say, what is your favorite color? So again, we can ask a question. So as we do this, it's going to give us different answers. Now you may realize as you start looking at this that, wow, this could potentially give us a whole lot of options, and I have to keep thinking of questions that aren't going to have overlaps between them, and then that could be complex. But what we can do is we can kind of make each question put us into a specific track. And when we're on that track, we will analyze the reasonable possible answers that would occur with that. So we could ask a whole bunch of different yes and no questions. And in doing so, we, based on what track we're on, will determine what the response is and what the follow-up question will be. So to see this a little bit better visually, what actually works really well is to flowchart it. Now there's all kinds of different ways you could flowchart it, different productivity tools for doing flowcharts. There's one, draw.io. Just ignore that. Allows me, which apparently brings me to apps.diagrams.net once I open it. If I go to draw.io, okay, so they've been bought. It was draw.io, and the format for the file is draw.io format because I made this in draw.io, and there's a standalone desktop app you can download free, or you can use the web version. So we start out, we say, hey, how are you? Now we're going to be analyzing their mood. This is our first analysis. And if we don't understand their answer, if they don't say good, if they don't say bad, it brings us into the unknown or our generic responses. But if they say good, we could follow up and say, what's your favorite color? Now we move into a color analysis. And if we don't understand the color they say, it drops us over back to our generics. Otherwise, now I'm going to, in my example, I'll look for red and blue. So if they say red, say, do you want a date? And now we have our love analysis. If they say blue, then we say, I thought you were feeling good. Do you need help? And now this is going to be moving into our sad analysis because they said blue, and then we have to figure out what that next question is going to be as we work our way through here. So what we're doing is figuring out how to track this. So if they say, oh, I feel bad, I'm going to say, do you like dogs? And under dog analysis, the options are yes and no. Hopefully they don't say maybe. If they say maybe, that brings us into generics. But if they say yes, then we ask now another question. And then we're going to move into the dog owner. Now that would probably be a yes or no question. So we branch out yes. What does that bring us to? No. What does it bring us to as well? If they say they don't like dogs, then we can now ask the question, do you have a cat? They say, yeah, I have a cat. That's, again, yes or no, as we figure out under that cat analysis, where is it going to go? So when we do this, each one of these things in a diamond is going to be a track that we are working with, and each one of the rounded rectangle boxes is going to be the response and question. So this is how I'm going to start setting up the project in code. So going back here, it's going to get really ugly if we end up with a super long if else, because we have to then nest it inside of, okay, our mood analysis and our dog and our cat and our love and all these different things. So what we're going to do is we're going to probably start breaking this into individual functions to deal with it, because then one, the code, well, it is going to be somewhat repetitive, and down the road we could look at an optimization to consolidate or refactor, but right now it's going to allow us to separate things so it's easier to both track and understand what is happening. So now I'm going to go back up towards the top where my variables are, and I'm going to make a new variable. I would very much discourage you from just adding the variable down here in between functions, because if you do that, it is going to get kind of messy. So I mean, I do have this section where we have the event listeners and these functions, which are all part of one group of logic. I could bury that at the bottom if I wanted, or I can just leave it here. But I took care of those because they belong together, and then that's all we're doing with them. So now let question track be equal to, and now the question track, when we start this out, the first one is I am asking for their mood. So my question track is going to be mood. Then what we're going to do here inside play game is I will say, now we can write this using an if statement, or I could write it with a switch statement. So I could say if question track is equal to mood, and we'll do our mood analysis. And then it will be else if question track is equal to, and let's see what went off of that offhand. Let's see. Fine. Oh, I'm not closing it. All right. Okay. Anyway, so we have mood, we have color, sad, love, dog. All right, I'm just going to do mood, color, and dog for now. Then I'll go referencing this, but then I'll reference my notes for my other parts of it. So color, couple curly braces, and then this will be color. Color analysis, else if, and so we can do it with ifs. And that will work. Now I do have to create those functions. And the final part on the else would be, at this point, our else would be generic response. That response is calculation, like that. And so when we're looking at this, just realized this line here will need to be before the if. So we calculate, because each one of these analyses are going to use it, because this is an analysis right here of the mood analysis. So what we need is to create that. So we'll just create all of those right here. So I'll have function mood analysis. And when I create mood analysis, I am just going to take that content right there and pull it down into that function right there. So what's going to happen is my game, as I add different tracks, we're going to get more options here. I'll also rewrite the whole thing using a switch statement so you can decide which you prefer. There's no right or wrong if you want to use switch versus if-else if. Both are perfectly fine. Now, right now, what I can do is copy and paste that, and this time I am going to change it and say color, and do it once more, and I will say dog. Well, not mdog, dog analysis. So, color analysis. So we say, what is your favorite color? If they say red, then we'll have a response, and if they say blue, we'll have a different response. Now, one thing I forgot to do is when we analyze the mood here, we need to change the track. Because if they said good, and we say, that's good for you, what's your favorite color? I need to set my question track equal to color. Now, if they say bad, we say, well, you're depressed. Do you like dogs? Well, let's set our question track. We'll set it equal to, in this case, I will say dogs. So now we're changing what that question track is, and I should have, before I copy pasted it twice, I should have got it correct, because now I'm having to add this in. Question track is equal to, and then to figure out what that statement is going to be. And I should have made a generic, oh, that would have been so much smarter for it, like that. And I'm just gonna make some generics here. Let's try again. And I'm going to take advantage of being able to Alt or Option click. Click, oh, I don't want that one there. Let's try again. So Option click, and Option click, paste. That puts it in for all of them. So now I can go and figure out what those different question tracks and messages are going to be as I start putting this in. So if under color analysis they say red, and I can say you sound romantic. Do you want to go on a virtual date? Okay, so the computer is a little bit creepy here. And then we'll put in date. Now we say, you know, I thought, because remember they said good, that brought us to color. You were good. And then we can decide you like dogs? And now under dogs, yes, no. So yes, then it becomes dog owner, because the question will be, so do I. Do you have a dog? And if they say no, you say, interesting. Do you like cats? And then I will change our track to cats. So as you can see, I may not be following my flowchart exactly, but I'm starting to pull things together with it. As now I need to put up, forgot to say, so color analysis brings us to dogs, or dog, and if they give us dog, then we are going to be able to then go into either dog owner or cats. Which, if I'm going to do dog, I'm actually going to do cat, just so mentally it's easier to keep track of. So if you build yourself a good flowchart, and you plan all of your different pairings of questions and possible answers and how you're going to snake your way through, what you're really doing is building the logic of your chatbot. You're building that AI of these questions that are using predictive logic to come up with what possible answers could be and what possible responses could be. So now let's save this and see what happens. And if I say good, it's my favorite color, and I'll say red. It's like, wow. Okay, creepy. All right, so now let's try again. I'll say bad, and let's say yes. Let's try again. Bad. All right, so yes is not working on it. Let's go figure it out. So if they say bad, change that to dog, but I didn't change that. So this is why, and now this is interesting, is because I have dog here, but I set my question track to dogs, therefore it keeps finding then, oh, we don't see dog, we have dogs. So we'll just go into our generic response because the question track was unknown. So let's try again. Now, bad, yes. So do I. Do you have a dog? Yes. And we haven't finished the logic to figure out where it's going to go next. So we're building up the intelligence here that it's really limited to how deep you want to go. Now, under each analysis, you do have the option. I mean, say color analysis, what's your favorite color? You could do red, green, blue, purple, yellow, orange. I don't know if I've ever met anyone whose favorite color is orange, but if yours is, leave a note in the comments below so I can find out. That would be kind of cool to see how many people have orange as their favorite color. But you can expand it out. So we have good and bad for the first question. If you want more possible answers, you could put that in as well. Chances are most people, if you ask them that question, they'll type good because they don't want to further the conversation. So that's what we're doing by furthering it. And then under the color, decide how many colors you want to analyze and where you want that to go. So your tree can branch twice with each option, or it could branch 3, 4, 5 times with each option. It's really just based on how complex you want to make it. And as you start building it, it's just rinse and repeat. You just keep adding in more tracks, and you add in more responses with the computer. The more detailed you are, the more realistic or thoughtful your chatbot is going to become, to the point that it will be creepy. It will be unnerving because it will seem to be almost real in its personality unless you go through it multiple times and you realize that it's giving those same answers. And then it becomes pretty much like the virtual chat on every website you go to these days, where it pops up, hey, I'm so-and-so, how can I help you? And you'd be like, go away. And it's like, oh, let me answer your questions. Fine, you type something in and you get weird responses. So this is your opportunity to build your own electronic personality.